Okay, so next we want to look at a situation where we have multiple forces acting onto our charged particle. So in this first case, we're looking at using Coulomb's law to clean the air. So the idea in this is that if you have a modern smokestack, it has a device called a scrubber, and essentially what it does is it sort of injects charge onto the soot particles. So they're very small particles, and then they're charged enough, and then if you apply an electric field, that then causes the soot particles to get pulled out of the smokestack. So instead of going into the atmosphere, they're stuck onto the collector. So in this case, we want to consider a soot particle, and what's happening is it's got a certain mass, a mass of 1.5 nanograms, which is 1.5 times 10 to the minus 12 kilograms. And this is a pretty small particle, so probably a few micrometers. So some number of electrons have been added to that particle, and so now it has a charge of Q soot. And the collector that is pulling it out of the air, so that has a charge of 1.45 times 10 to the minus 6 coulombs. The separation between the collector and the soot particle is 0.2 meters. And so the question we have is, what is the magnitude of the charge on the soot particle so that the electric field exerted on the particle is equal to its weight? So its weight is mg. So to figure this out, probably the first thing is we want to draw a free body diagram. So we have this guy here, and so pointing down, our weight force is weight 1e, and then it looks like our soot particle here, so it is getting pulled to the left. I guess I will call that force 1e, since it's the force by the electric field. So what we know now is that the magnitude of these two forces are equal to each other. So F1e is equal to weight 1e. So weight 1e, that we know, so that is going to be mg. So that's going to be 1.5 e to the minus 12 kilograms times 10 meters per second squared. So weight 1e is 1.5 e to the minus 11 newtons. All right. So now we know that that is also what force 1e is equal to. So force 1e is equal to 1.5 e to the minus 11 newtons. And then that is equal to the value from Coulomb's law. So that is going to be k times q1 times q2 over r squared. So to take care of the numbers here, so this becomes 1.5 times 10 to the minus 11 newtons is equal to 9 times 10 to the ninth for your Coulomb's constant. Q1 is the charge of the collector. That is 1.45 e to the minus 6 coulombs. Q2 is what we're trying to solve for. And then the distance here is 0.2 meters squared. So we have some rearrangement to do. So we want to solve for our Q2 here. So Q2 is now going to be what here? 1.5 e to the minus 11 newtons times 0.2 squared divided by 9 e to the ninth and divided by 1.45 e to the minus 6 coulombs. So we do our math on this, and this comes out to be what? 4.598 e to the minus 17 coulombs. Okay. So that's the amount of charge that we need in order to induce that sort of force. So not too large of a charge here. So our follow-up question is how many electrons are required to be added to the soot particle? So we've just found the amount of charge. So to do this, the number of electrons, we'll call that n, and we multiply that by the charge of an electron, which is negative 1.6 e to the minus 19. And that is then equal to the total charge, which is 4.598 e to the minus 17 coulombs. And so now we just divide 4.598 to the negative 17th divided by the electron mass. And so we do that, and we get about 287 electrons. Okay, so yeah, that's the strategy on this. So we find the force, and then we set the force equal to the Coulomb's law, and so then we can solve for the charge. Once we know the charge, then we can figure out how many electrons are required to do that. Okay, so now we have another problem where we have multiple forces going on. So in this case, we have a small glass bead, and it's charged by the removal of 5 times 10 to the 10th electrons. So the question then is, what electric field strength, in units of newtons per coulomb, will cause the bead to hang suspended in the air? So to start with here, we want to draw our free body diagram. So pointing down, we've got gravity, so we'll call that weight 1e. And then pointing up, we want our force 1e, so that is our force caused by the electric field. So what we know is that force by the electric field is equal to the negative of the weight 1e, right? They're equal in magnitude and opposite in direction, and that way the bead will hang suspended in the air. So to figure this out, again, we'll have to find weight 1e. So to do that, we want to do mg. And so remember, in this case, we want mass to be in kilograms. So in kilograms, 6 grams is what? 0.006 kilograms times 10 meters per second squared. So this guy is 0.06 newtons. So that means that the force by the electric field, so F1e, is equal to 0.06 newtons. And that also, to find the force caused by electric field, well, what we do, we multiply the charge by the strength of the electric field, and that then gives us the force. So that means we need to find Q. So to find Q, in this case, we aren't given the charge in coulombs, we're given the number of electrons. So that means that we take our 5 times 10 to the 10th electrons, and we multiply this by the charge of 1.6 e to the minus 19 coulombs per 1 electron. And so I guess I should make this negative since our electrons are negatively charged. And so if we do this, that means our charge is negative 8 e to the minus 9 coulombs. So that means that our force 1e is equal to the 8 e to the minus 9 coulombs times the electric field, and that is equal to the 0.06 newtons from before. So we can then solve for the electric field by dividing by the force divided by the charge in coulombs. And if we do this, we get our charge is 7.5 e to the minus 6 newtons per coulomb. So this is another example where we're looking at multiple forces acting on an object. Here we've got the weight force and electrostatic force acting at the same time. So this is nice. It combines a couple concepts that you guys have done before, gives you a little reminder of how forces work. All right, I think we'll stop here for this lecture. So it's kind of a synthesis thing. We're putting together some ideas we looked at before. So don't forget, you do have a homework assignment due next Monday. So it's due Monday this time, since last time it was Tuesday because of DropAd. So it's now, the homeworks are going to be due on Monday from now on. And beyond that, have a good weekend and good luck.